I'll share a short or brief history of Linux. We'll look at Linux usage statistics, but we'll show you a tour of basic Linux commands. So what is Linux? So Linux is a modern free operating system based on Unix standards. It was first written by Linus Torvalds of Helsinki, Finland on September 17 in 1991. The Linux source code is licensed under the GNU Public License version 2. Because of this, it is free software or open source software. The Linux operating system is developed collaboratively with users all over the world, and most of them correspond via the internet. It was originally written for the Intel 80386, but it has been ported to a variety of processors, and therefore it's a portable operating system. When the Linux kernel was written, no Unix source code was used, but by design, it was aimed to be POSIX compliant. And because of this, it can run much of the existing free Unix software, notably the GNU utilities and other Unix programs. It is a true multitasking, multiprocessing, and multi-user operating system. Networking is built into the kernel. The Linux kernel, which is at the heart of Linux systems, is the base of Linux distributions, including systems such as Android or Tizen. So if, for example, you're running or using an Android phone right now, you're already using Linux. So the Linux source is written in the C programming language. And inside the source code, there is also inline assembly language for the target platforms or architectures. And initial support for the Rust programming language was added to Linux in version 6.1. I listed there the website kernel.org. This is where you can actually download the Linux kernel. So this is a picture of Linus Torvalds. He is the author of the Linux kernel. In 1991, he was a master's student at the University of Helsinki in Finland. Linus is now a fellow at the Linux Foundation, and he oversees the work of continuing development of the Linux kernel. So let's take a look at what Linux is. What is an operating system? So in our diagram, we see that at the bottom, we have our hardware. This is the physical components of our computer systems. Linux is an operating system and is at this layer. The Linux operating system is what's responsible for talking to the hardware. So your applications, for example, your web browser or your word processor, these applications don't talk to the hardware directly. Instead, your applications talk to the operating system. At this level here, this is what you call your system call interface. At this point here, your operating system has interfaces that talk directly to the hardware using device drivers and other such modules in which are part of the kernel. So the Linux kernel is at this layer, but our Linux system actually comprise comprises both your operating system as well as your applications. So in this chart, we'll see different layers within Linux. So at the bottom here, this is the actual Linux kernel. And this is what's responsible for talking to your hardware, your CPU, your main memory or your RAM, your disks, and other devices. So part of the Linux kernel at this interface, you have your system calls. So in the upper layer, you see the user mode, and this is where your applications reside. To talk to the operating system, we have what's called your C standard library. We'll see a bit about this later when I demonstrate um, the command line. Okay, so here's another diagram where we see the architecture of our um, system. So at the bottom, you have your hardware platform. In the blue box, you have your Linux kernel. Here we have your architecture dependent code. This includes your device drivers and anything that talks directly to the hardware. This part of the Linux kernel talks to the electronics using interrupts. Then here in the middle is your core kernel functionality. Included here, we'll see a detailed breakdown of the kernel modules later on. Then we'll see here that there's the system call interface. The system call interface is what allows your Linux kernel to abstract access to your hardware. There are about 300 or more system calls in the Linux system. So this is a little bit more detailed breakdown of the components of your kernel. So you have your device drivers and then your architecture dependent code. Then the Linux core consists of your process management, memory management, your virtual file system, your network stack. Oh, and I forgot to include your system scheduler. These different components are what manage the resources on your computer system. And at the top here, we have your system call interface. This system call interface is what your applications actually use to communicate with the operating system. So here's a more detailed map of the Linux kernel. And you can see here at the bottom, you have your hardware. Then your hardware interfaces consist of your device drivers, then your CPU specific code, and then your code responsible for physical memory operations, and so on and so forth. So as we go up the diagram, this moves closer to what our applications see in the system. So here's another diagram that shows us the relationship between your Linux kernel and the different types of hardware. So, by the way, itong penguin na 'to, ito yung mascot nung ano, ng Linux. The penguin is the mascot of the Linux project. So most of the time when we refer to Linux penguins, we use the penguin as your representation of Linux. Okay, so um, here we see that the Linux kernel is supported on these different architectures. We have your supercomputer, computer cluster, and mainframe computers that run Linux. We also see that Linux runs on desktop computers, server computers, mobile computers, and wearable computers. We also have embedded computers that run Linux. On the leftmost side, we see the different types of hardware that we can attach. On the right side, we see a list of different application and system software that can run on top of your Linux systems. Okay, so let's take a look at the market share of Linux in the world. And this is based on StatCounter Global Statistics that was retrieved on October 22, 2024. And we see that Linux is on the desktop is a paltry 1.6%. But if you'll notice, the number one operating system all over the world is actually Android. Your Android phones, pinakamarami sa mundo. So it comprises 45, or is that 45? 49. 45% of operating system usage in the world. Note that your Android phones run the Linux kernel. This is different from your Linux desktop, which runs on your PC. No? Okay. In the mobile space, Android has a majority of 72% all over the world. In desktop operating system space, Linux only clocks in at 4.5%. Windows wins the desktop, but on your tablets, but on your tablets, the winner is the Apple iPad OS, followed by Android with 45%. But let's look at this. The top 500 supercomputers in the world, all of them run Linux. The top 500 supercomputers in the world have been running Linux 100% since 2017. Not only that, let's take a look here. So if you want to check for yourself, you can go to the top500.org website. Now, in the server space, Linux dominates. Linux takes a 62.7% market share of your global server space. This is true also on your cloud environments. Linux dominates even in the Azure cloud, Google Cloud, and Amazon Web Services platforms. Okay, let me talk about the four freedoms of free software. So Linux is free software. And what do we mean by free software? So the four freedoms include the freedom to use, the freedom to study, the freedom to share, and the freedom to improve. So in the freedom to use, we're able to run and use the program for any purpose, and it is free of restrictions such as license expiry or geographic limitations. So as long as you have a copy of the free software, you can use it for any purpose. Free software also is uh, free to study. You can study the source code because the source code is made available by free software. You're also allowed to share free software. When you receive a copy of free software, you can in turn copy it for your neighbor. We're also permitted to share and improve the software. By improve the software, this means that if you modify the source code and then make improvements to the software, you can share those modifications with others. There's more information about these four freedoms of free software at the Free Software Foundation website and Free Software Foundation in your website. So let's take a look at Linux distributions. Linux distributions are also known as distros. These are a bundling of the Linux kernel, along with other software like software for package management, a general file system layout, what's known as an init system, and a shell that's pre-selected for you. So these Linux distributions are like different flavors of Linux. There is no single Linux software, but if you look at the different distributions, they are what make it easier for you to install a complete working Linux system. Without a distribution, you would roll your own by downloading all the different component software sources and compiling them yourself. An example of this would be the Linux from scratch distribution. It's actually not a distribution. So some early Linux distributions include Linus Torvalds' own boot root images, which he released in November 1991. Subsequently, we had other uh, small distributions like the MCC Interim Linux distribution, Soft Landing Linux Systems, HJ Loose bootable root disks, and finally your Yggdrasil Linux. Most of these distributions were floppy disk based. Okay, so floppy disk, they came in floppy disks and you would install them onto your hard disk. This last distribution, on the other hand, came on CD-ROM. The two oldest and still active distribution projects started in 1993. And the first of these was the Slackware distribution. Okay, because there was an earlier distribution, itong this distribution, soft landing systems. This was one of the popular early distributions. So what happened was, because it was not well maintained, this guy named Patrick Volkerding started the Slackware distribution. The other distribution that resulted from SLS is the Debian project. And this is one of the most influential distributions in the Linux world. It's primarily community driven. Okay. So we have the following Linux distribution families. You can categorize them into three. The first would be your Debian based distributions. They use the .deb package format, and examples of this would, of course, include Debian. Then the Ubuntu Linux is also a Debian-based distribution. You have your MX Linux, Linux Mint, Deepin, Kali Linux, Pure OS, Trisquel Linux, Dev1, and Knoppix. There are many more, but these are the uh, main ones that I was able to identify. Then you have your Red Hat based distributions. These use the .rpm package format. And the main example of this would be your Red Hat Enterprise Linux, of course. Then they have the desktop version, which is Fedora Linux. Then also your CentOS, which is a freely available version of your Red Hat Enterprise. Then you have SUSE and OpenSUSE. These are your representative Red Hat based distributions. Then you have your others which don't fall under your Debian based or Red Hat based systems. Notable distributions here would include your Gentoo, Slackware, and Arch Linux distributions. So let's take a look at the distribution family tree. Uh, okay. So if we look at this website, here we see the family tree of distributions, and we'll see all the different distributions. Remember that all of these have the Linux kernel at their core, and then a collection of software that they have deemed worth putting into a collection. So this site, DistroWatch, gives you a list of the most popular distributions. Currently, we have Mint is the current number one. Then you have MX Linux, Endeavor OS, and then Debian. um, this ranking is based on popularity. Okay, so this is not an indication of whether it's really good or not, but there. So let's take a look at another thing. Okay, so I've introduced you to the different Linux distributions. Now let's take a short tour of what it's like to actually access a Linux system. So to show you what um, Linux looks like, let's shift to my desktop. So this is my desktop, and I'm actually running. So this is a Debian system running on inside Oracle VirtualBox. Let me close this window. Okay, so this is what you would normally see in a basic Linux system. This is your login screen. It identifies itself on the upper left, and you see that it says it's Debian GNU Linux 12 Debian TTY1. This tells us that it is that we are looking at the terminal number 1 on the system. So at the login prompt, we enter our username or login name. My login name is usually this XENOS, after which it will prompt you for your password. If you're able to successfully enter your password, it will show you a message of the day. Then it will tell you when you were last logged in, and it will give you what's called a prompt. So we're logged in now to this terminal. We can switch our virtual terminal by using Alt F2. And you see here at the top, we've now switched to TTY2. This is the second uh, terminal of your Linux system. And you'll notice this is all text, no? Because I didn't install a graphical user interface on this system. On this second terminal, I can also log in. Let's say I made a mistake in my password. It will, of course, reject my access, will tell me login incorrect. But if I'm able to log in properly, it will allow me to go to your terminal prompt again. So we see here at the bottom, I'm able to give the Linux system a command. Let's say I've done my work. I can now exit. I can use the command exit, and it will return to the login prompt. Okay, I'll go to the other terminal also. So this is the other terminal. This is TTY1. And the other command that we can use to get out of the system is log out. One of the features of the Linux operating system is that it is a multi-user system. So you can actually have many terminals that are connected to a single computer and have multiple users accessing the system at the same time. All right, so this is your basic terminal. Let me switch now to a different distribution. We're going to look at the Fedora distribution here. So this distribution is Red Hat based. Okay, so This is the graphical user interface of a Linux system. Notice that I can click on my name here. It's not responding. Let me try that on another. Oh, there you go. Took a while. So there, I'm able to log in. It's a little sluggish because I'm actually running this inside a virtual machine. But I just wanted to show you that there is a graphical user interface for your Linux system as well as a text-only interface. I'll switch to a different system because this is not responding to me properly. So let's try. Okay, so this one is KDE desktop environment. This is on K Ubuntu setup. So the delay is a little noticeable because, as I said, we're running this inside a virtual machine. So I'm actually running a Linux system inside a Linux system. Okay, while we're waiting for this Kubuntu to respond, so we'll now go to your whirlwind tour. So at its most basic, so the standard prompt for a Unix system is this dollar prompt. And when we see the dollar prompt, this means that the Unix or Linux system is waiting for a command from us. So similar to what I showed earlier, when you log in, you would get a prompt similar to this, and that application is called your shell. The shell is responsible for talking to the operating system. Your shell is also responsible for loading or telling the operating system what programs it that you want to load into memory and execute. So for example, we will start with a simple command. The first command that we're going to learn is who. When we run this command, it will tell us who is logged in to the system. Another command that we need to learn is the passwd command. If at any point during our session we want to change our password, we use the command passwd. Changing password for xenos. It will ask me for my current password. If I give it the correct password, it will now ask me for a new password. I'm going to not give a good password. Okay, so this is this command passwd is used for changing your password. Okay, so who passwd, and then let's take a look at another command. The next command that we're going to look at is the id command. This lists our user ID as well as my login name. It also lists my primary group ID, which is 1000. And then this is the group name. It will also list all the other groups that I belong to. This ID is a numeric ID. Since our system is a multi-user system, each user will have a unique user ID. There is an ID, there is a user on the system that has an ID number of 0, and this user is called your root user. So let's take a look at that in this file. So the root user has a user ID of 0, and because of this user ID, he will have this user will have complete access to all the files, all the system applications, etc., etc. This root user is your system administrator. Other terms that refer to the root user as the super user. Okay, so let's take a look at what's called a system call. So this is a short C program that I wrote, and it uses what's called the get UID system call. So if we look at the man page for get UID, we see here that this is part of the system calls. These functions are what we call your system calls, and these are the C functions that talk to the Linux kernel. And these are defined by your Linux system call interface. So if I compile this program using our C compiler, this will generate an A out binary, which we can actually run. So it tells me what my user ID is and the effective user ID. We'll come back to this later, but we'll see that this program that I created returns a similar output as the ID command. So 1000. So the ID command uses get UID as one of the system calls along with these other output it generates. Okay, so application programs use system calls to talk to the Linux kernel, and the Linux kernel performs the function that it was requested to do. So applications are actually collections of all of those system calls along with your other functions. Okay, so let's take a look at another command. So another command that's interesting for us is the hostname command. The hostname command will tell us the name of the system that we're logged into. Next is the uname command. Let's run it without any options. So uname will return the operating system name. And we see that uname will return Linux as the operating system. If you try this command on Mac OS, you'll see that this will show the Mac OS kernel instead of Linux. Okay, so commands can be passed what's known as arguments or parameters. Usually, arguments or parameters can be prefixed with a dash or a double dash to denote a switch. So if we run uname with a dash a argument, it will now return the name of the operating system as well as other information. More information, including version number, and so on and so forth. Next command we're going to look at is called the echo command. By itself, echo will display a blank line. If we give echo a string as an argument, it will output that string. This command is also useful, for example, if we want to take a look at what are called environment variables, we can use echo. Then you have your dollar symbol. This tells the echo command that the next part of the command is a variable, and we want to see what the value of the variable is. So if I type echo dollar path, this will return what's called a path name. This is a list of directories that our shell will look in when it is looking for a command that is not built in. If I tried that command again, echo path without the dollar string, you'll notice that it will output the string path. So the dollar in the string tells us that I want to look at what's inside this path. Okay, so another command that we can look at, so echo user. So this is another way that we can check what user is currently logged in using the dollar user string. This will check the user environment variable. Another command that we can use to check the username is who am I. So you'll notice that there are many different ways of getting the same answer from our Linux system. And each of these commands will have their strengths and weaknesses. So as you learn more about the Linux system, you'll see that there are different contexts in which you will use a specific command. Let's say we want to know more about the commands that we just used. There are three different commands that we can use to learn more about the commands. So the first one is the help command. So if by itself we type help, it will tell us what commands it can give us more information about. The help command documents what are known as built-in commands of the shell. So for example, if I type help, it will tell me that this is a command that displays information about built-in commands. Okay, so that's the first command for getting help. The other command is called your man command. The man command is short for manual. So if we use man followed by the command name, for example, man, we get what's called your man page. The man page is actually an electronic representation of pages in a manual, a book, or a set of books that documented the different commands for the Unix commands or the Linux commands. Okay, so man is an interface to the system reference manuals. Notice that in the man command at the top, we see that there's the man followed by a number inside a parenthesis. This tells us what section in the manual the command that is being described is located. The third command that we can use to find out documentation from the Linux system is your info command. So if you run info by itself, this will give you the main menu for the info command. Okay, let's take a look at what are known as your. So the next command is your pwd command. This is short for print your working directory. Okay, so this is what it means, print working directory. When we log in, the first directory that we're actually in is called our user home directory. So if, for example, kaka-log in ko lang, this is the home directory of this user. Home/home/sinos. Your directories are what we call your current folders in modern terms. No, the folders are actually the same as directories. They are just a metaphor of the desktop, because with the advent of graphical user interfaces, it was easier to think of directories as an analogy for folders. So your folders would contain files. In a similar way, directories are actually special files that contain other files. So if we use the command cd, this is short for change directory. Without any options, cd will change directory to this user's home directory. So when I type cd without any options, it returned me to my home directory. The Unix file system or the Linux file system is what's called a hierarchical file system. And at the base of the hierarchy is what's called your root directory. And we can go to the root directory by typing cd space and then slash. The slash is what we call our root directory. If we think of our file system hierarchy as a tree, the root directory is at the base of the tree. Okay? Let's take a look at a new command, and the new command is called ls. ls will list the contents of the current working directory. So list contents of current working directory. Okay, so we're at the root directory and we can see that inside our root directory, we have all of these files. These are files or directories. If I type cd again, it will return me to my home directory. Cd followed by a dash will change directory to the last previous directory. Okay, so it will bring me now back to the root or slash directory. Now there are two types of path names in Linux, and we have what are called absolute and relative path names. How do we tell the difference between an absolute and a relative path name? Absolute path names will always have a slash or the root directory at the start. Relative path names, on the other hand, will not have the slash at the start, and they work only relative to the current working directory. So relative to current working directory. Okay, so for example, if I cd back to my home directory, this is my home directory. If I cd to Linux fundamentals, this will bring me to a directory known as Linux fundamentals, which is inside my home directory. Okay, so in Linux, your directory separators are your slash character. So if we're going to read this, this tells us that inside the root directory, there is a directory called home, and then there's a directory inside that called Synos, and then there's a directory inside that called Linux fundamentals. So let's take a look at the contents of this directory. ls without any options will show us what's inside the directory. We can use the ls command with the dash capital F. This will now show us the output with slashes at the end of the name to tell us that this is a directory, or an @ sign. This will tell us that this is a symbolic link. And then you have your pipe character. This will tell us that it is a pipe. We can look at ls with an dash L. This will output what's called your long format output for ls. And this is a command that you will use a lot. Okay, so ls-l will produce the output where on the left side we see what are known as your permissions along with your symbolic link and all that. Let's take a look at ls and then okay. So this is the output of ls-l, and we'll see there that the very first column tells us if it's a file, a directory, or a special file. Then the next 9 characters tell us what are the permissions of the file or directory. Then if any of the files or directories have a special access method, it will indicate it there with either a plus sign or a different symbol. The next column will tell us number of links that point to that entry. The next column is the user owner, and then the next column is your group owner. Following that is your size in bytes. Then the next column is your timestamp. By default, the timestamp that is displayed is your last modification time. And then the last column is your file name or directory name. So if, for example, I type ls directory, this will list the contents of the directory if there's anything inside. So let's use a command to create a file inside that directory. So we can use the touch command to create an empty file. Okay, so touch followed by directory slash file created that file. And then when we typed ls directory, we see the contents of directory. We have that file now. If we type ls-l directory, it will output the long format information for the file or directory.